You need to forget about your AWS VPN. Seriously, just forget it. Because there's a much better way to securely access all of your AWS infrastructure. The key lies in a product called Twingate, a zero-trust networking solution that makes it easy for authorized users to access your AWS network, while at the same time making it impossible for hackers to gain access. But before we can get into everything Twingate has to offer and why it's a better option than more commonly used services like AWS VPN, we first need to understand some of the well-known security vulnerabilities in a traditional VPN setup. Most VPN products are based on a concept called castle and moat. In this model, your assets are safely housed within your castle and protected from the outside world. Thanks to your moat, bad actors are easily prevented from accessing your network. With a standard VPN, authorized users can use a bridge to cross the moat and gain access to the castle. The problem is, once a user is in, they have free reign over all of the resources in your castle and are free to pillage and plunder all of your sensitive data. Usually this problem isn't much of a concern, since we only give access to employees or other authorized users. But these days, hacking methods like malware, phishing attempts, and others are increasingly common, and a momentary lapse in judgment can grant a bad actor the keys to your kingdom. Unfortunately, a headline like this one is just far too common. But the good news is that there's a much better way to prevent these types of risks altogether. The key is in the concept called Zero Trust Network Access. Zero Trust networks use a security model that assumes that there could be bad actors both outside and inside your network. Therefore, by default, nobody is trusted unless they've been granted access to a specific resource. Additional safeguards like enhanced device security and default access policies are secondary layers that add even more security to your zero trust network. Small companies or even large ones that require secure access to their AWS networks often default to using the AWS Client VPN service. But unfortunately, Client VPN does not use zero trust network access, and this makes your company's assets vulnerable to external actors. Twingate, on the other hand, is a robust zero trust networking solution that is easy to set up, simple to use, and most importantly, is a fraction of the cost. It also has a whole bunch of other built-in security features that make it something worthwhile to consider. So let's do a quick comparison between AWS Client VPN and Twingate before jumping into the Twingate console and showing you how it works. In terms of initial setup, AWS's Client VPN is a fully managed service, so you would expect things to be simple. However, it does have a bit of a steep learning curve, especially if you decide to enable many of the optional bells and whistles that come with the service. As a user, you follow a predictable setup wizard answering some common questions to create what's called a Client VPN endpoint. After it's created, you associate your endpoint with a subnet in your VPC. This essentially allows an entry point into your network to the specific subnet. One thing I want to emphasize is that Client VPN is not the type of service where you can wade through the console selecting options with varying degrees of certainty as to what they do. You will definitely need to read the AWS Client VPN documentation to understand some of the nuanced details of setup and to get it working correctly. Once your endpoint is set up, you have to download a client configuration file that tells your users how to connect to the endpoint. Twingate, on the other hand, has, in my opinion, a much more streamlined approach to setup. In fact, in a previous video that I created, I described to you how Twingate works under the hood, and I walked you through the initial configuration. The summary of the setup, though, is this. First, you create a Twingate network in the console. You then copy a command from the Twingate website and paste this command into your CLI on your AWS account. After Twingate deploys some necessary infrastructure to your account, you're pretty much done. It takes less than 5 minutes to set up and is easy to do even for those of you that aren't experts in AWS networking. So that's a little bit about setup. Let's move on now to authentication. Authentication is the process of proving you are who you say you are. The most common way to do this is with a username and password. For AWS VPN, you'd think that it would use the same method, But unfortunately, this isn't the case. The standard way using Client VPN is to use certificate validation, which involves an administrator creating a certificate for the user and hosting it in AWS Certificate Manager service. You as a user then need to download and associate this certificate with your OpenVPN client. Although certificate-based authentication does work, it's a bit cumbersome to set up and prone to some security vulnerabilities if not configured correctly. Alternatively, you can connect your client VPN to an AWS directory that contains a repository of users, but that requires setting up and integrating with a whole other separate service. Twingate, on the other hand, uses a traditional username and password based approach. As a user, you're invited by your administrator to create an account, and afterwards you use the Twingate provided VPN client to connect to the network. Alternatively, you can also import your users into Twingate from common identity providers like Okta or Google Workspaces. A key advantage that Twingate has over Client VPN is the comprehensive number of device security requirements that administrators can enforce on connecting users. For example, you can require that a connecting user has certain security features enabled on their device, things like antivirus, a firewall, hard drive encryption, or a screen lock. Administrators can even see the specific status of each connecting user's device and choose to verify it. Overall, Twingate offers a more familiar-based authentication process and more powerful plus easy to set up security features. Authorization is all about giving approved users access to certain resources. As we touched on earlier with our castle and moat example, standard setups like AWS Client VPN have limited abilities to restrict users from accessing resources that you'd like to keep private. With Client VPN, you do have some control over authorization, but the features are quite limited. For example, you have the ability to create things called rules that allow a user to only access a particular IP space of your cloud network. Further, you can add an additional layer of restrictions using security groups, where you can explicitly say that a particular resource can only be accessed by users connecting through your client VPN. However, this does not give you the ability to restrict connectivity to only a subset of users that connect. Although resource-based security is somewhat possible in this model, it's not easy to set up, maintain, or monitor. Now, because Twingate offers zero trust network access as a main feature, the level of control administrators have over resource-based access is much more robust. The simplest way to grant network access to a resource is to grant that user explicit permission. But as your user base grows, this can quickly become a nuisance. Instead, you can create groups and associate each user with one. That way, you can just assign a user to a group, and all users within that group inherit access automatically. On the monitoring side is where AWS Client VPN really has trouble. The only really way to monitor your network is using verbose CloudWatch logs that are not very user-friendly to understand. Sure, you can pre-create some CloudWatch queries to parse and analyze them, but who wants to do additional work for such a seemingly obvious feature? Twingate, on the other hand, does an excellent job with monitoring. Administrators have access to a feature-rich dashboard that contains live activity logs of users attempting to connect to the VPN. This makes auditing a breeze. Clicking on each entry provides users with the connection details. And if you want to audit specific users or resources, you can do that too. This makes it super easy to analyze what individual users were doing on your network and when. Pricing is the final and most important piece to understand about AWS Client VPN, and in my opinion, is its biggest downfall. In Client VPN, you're charged for each endpoint association that you create. Client VPN endpoints are akin to VPN gateways in a traditional setup. In this case, you need to associate each of your endpoints with a particular subnet in your network. Depending on the number of concurrent users you need to support, you would create multiple subnet associations. For each association you create, you're charged between 10 cents and 15 cents per hour. This is an overhead administrative cost of using Client VPN. Secondly, you're also charged based on usage. For each user that connects to your VPN, you're charged 5 cents per hour or $1.20 per 24 hours. This is a trivial amount of money for a small quantity of users, but this dollar value can quickly explode if you have hundreds or even thousands of users attempting to connect to your network. Twingate's pricing uses a flat fee structure for each user that you bring into your network. The free tier lets you use Twingate for up to 5 users without paying a dime. Keep in mind that you don't get access to all the bells and whistles offered in the other plans. For small to medium-sized companies, the Teams plan supports up to 100 users and costs $5 per user per month. You also get access to some additional features like MFA requirements and SSO. For larger companies needing to support up to 500 users, the business plan is what you need. It costs $10 per user per month and gives you access to all the features that Twingate offers. There's also the enterprise plan for those of you that need support for more than 500 users. Now, if you're still a little hesitant on the pricing of AWS Client VPN versus Twingate, you can use this handy calculator spreadsheet to estimate the cost difference. For example, here I selected 25 users with about 8 hours of usage per day. By going with Twingate over AWS Client VPN, you can save over 38% or almost $1,900 per year. At this point, I hope you can understand the difference between AWS Client VPN and Twingate. Let's now dive into the Twingate console to see what it's like as a user. So here we are in the Twingate console. This is the overview page for an existing network that I've already set up and configured with my AWS account. And this is actually the overview page where we have access to a bunch of administrative information to help give us more insight into how users are interacting with our network. So this is typically where you would come if you're an admin trying to understand, how many users do I have, what's happening, who's connecting to what, and also to look at recent audit trails. So if we take a look at some of the information here, we have at a glance network insight, so we can see how many active devices there are, how many resources there are that we've associated. We'll talk about this a little bit later. How many remote networks that we've associated with Twingate. So right now I just have my one AWS VPC associated with it, which is why it's showing 1 here. Connection history in bar graph form. You can see a couple days ago I was having some trouble connecting. So it shows you kind of when failures were occurring as well. In addition, successes just earlier today. This is also an interesting part where you can see some of the audit trail information. So this is like me trying to connect to a specific EC2 instance that I onboarded onto Twingate earlier. And if you click on show details here, you can see some very specific information. So you can see the event, the username, the type of machine the person was using, the IP address, what IP address they were trying to connect to, the protocol. There's a whole bunch of other information here that you could take a look at. It really gives you a ton of context as to what was happening when this connection was initially established and also when it was closed as well. So tons of context that's available to you. Okay, so let's go through some of the main ideas here, the main concepts, and talk about them one by one. So like I mentioned, I already set up a remote network. I connected Twingate to my VPC already. If you want to see how that's done, I suggest watching my other video on Twingate, which I'll link in the description section. But let's just take a look at kind of what was set up initially. So we have this thing called remote networks here, as you can see. And so this is the remote network, the VPC that I set up and linked to Twingate and my AWS account. And you can see also that there's this concept of connectors, and connectors are those small pieces of infrastructure that are deployed into my AWS account that facilitate the interactions between the AWS network and Twingate itself, and also client connection. So this is kind of the middleman here. And you can see that there's 2 different connectors. So I only have one configured right now, which is totally fine for just kind of a demo or a small company. If you want additional redundancy, you want to protect yourself, like maybe an availability zone goes down, this machine is no longer working in AWS, you would deploy 2 connectors. Keep in mind there's additional cost for that. And then you can also see the resources that I have set up. So I've already associated this Twingate network and my AWS account with this EC2 instance, also called a resource in the terminology of Twingate, with this network. So if we click on this, this will actually bring us to the same place if I were to click on resources up here, but I'll just show you how to do it through this view. If you click on this guy, you'll be able to see the details of this instance. So this is the private DNS of an EC2 instance that I have in my AWS account. You can also see some of the information here in terms of connectivity over time, to who has access to this. So right now I have access that's permitted for 2 groups. One is the default group and one is the DevOps group. I'll show you how to configure groups a little bit later. But if we take a look at my AWS account, I just have it open on another tab here. You'll see that I have an instance over here. It's called the web server instance. And if I click on this, we should be able to see the same private IP DNS DNS right here. So IP 172-31. And if we go back to the account, we should see, 172-31. Keep in mind that this is a private instance. This does not have a public IP address. This is something that is only accessible either if you're in the AWS network or you're accessing it via Twingate, which is pretty cool. There's no public exposure here to your resources. Everything is kept behind this network access. So that's something that's pretty neat. So that's how resources work. And if you wanted to add more resources, it's very, very easy to do. Say you had an RDS database or an ECS cluster or I don't know, some other type of infrastructure that's deployed in your account. You can easily do that by clicking on plus resource here. This just walks you through the wizard. You give it the private IP address, you add a label. You can also add some aliases and which ports you'd like to restrict for this particular resource. But it's pretty straightforward to do and set up. Again, defer to my other video to learn more about how to do that specifically. I think I set up an RDS instance in that video, which was pretty neat to see how it worked. Now, one other thing about this concept of remote networks. Now, I set up the AWS network here, but this is just a single VPC in a single account. The beauty of Twingate is that it kind of unifies all these different remote networks that you can have in different ecosystems, including on-premise, including Google Cloud or Azure or whatever you may have. So it kind of unifies everything together into a single network space. So you can just go around SSHing into things as if you're on one just home network. And so if you wanted to add an additional network using any of these other cloud providers or on-premise providers, you would simply go to plus for remote network up in the top right here. And then you can see the location. Previously, I did the AWS one, but there's also Azure, Google Cloud, on-premise, or other if you want to do some custom stuff. And this process, if you click on one of these, you can add a additional one. You got to configure some connectors and do some additional setup for the specific type, of course. But this allows you to unify everything, which is pretty cool. Okay, so that's a little bit of a overview of what is going on here. Now, the next thing I want to talk about briefly is in terms of teams. Now, one of the beauties of Zero Trust Network Access is this concept of having additional users and having users that get explicit access to particular sets of resources. And so there's a couple different ways that you can add users. Right now, I only have one user, which is just myself. But if you wanted to add another user manually, you'd click on this plus button up here just to add a user. You literally just type in the person's email. They'll get an invite to your network. They sign up with an account, and then they'll just show up right here. Now, once you have another user, you can add them to specific groups. You can see in my case, I belong to 2 different groups. Now, one thing you can do right off the bat is that say this is like some kind of malicious user or you don't recognize this person, you can immediately go here, click on the little 3 dots here, and then go to disable or delete. Now, because I'm an administrative user, I don't think I'm able to do this, but this is just something that you should know about as a kind of break glass kind of scenario where, hey, someone's on my network, don't know who they are, let's get rid of them really quick. Okay, so let's walk through kind of the group section now, which is how you add and associate people with groups. So by default, when you create a Twingate network, you're just going to have the everyone group. You can see that whoever is part of the everyone group, which is just me, will have access to the HTTP web server. Now, I also created these 2 different groups just to demonstrate how this works. So we have a DevOps group, and then we have a software developers group. Now, this software developers group has access to no resources. So if I created a new user, added them to this group, they won't get any special access to any particular resources because nothing is associated with this particular group. And so in the case of everyone, this is something maybe you would only want to add common resources to, maybe just like common pieces of infrastructure that people may need. But generally, I wouldn't suggest adding any resources to everyone beyond what you want everyone to have access to. So this really lets you be a little bit more fine-grained in who you give access to what. So if we click on this DevOps group, for example, you can see that I previously associated with this web server group. And what I can do if I want is I can remove access for this. So I can remove access for anyone that's in this group to the web server. And now there's no resources that are currently accessible, same as the software developer group that we saw before. And if I want to just re-add that really quick, it's very simple to do. Just click on add resource. Then we click on the specific one, add the resource, and then anyone that is part of this group will automatically get access. You can also delete these groups and just disable them if you want as well. But but it's a pretty neat way to kind of scale up how you administer your different permissions to different users as opposed to just doing it one by one. Okay, so that's a little bit about groups now. In terms of this tab here, services. Now, services are a way for you to provide programmatic access to your infrastructure in your Twingate network. So things like headless browsers or CI/CD pipelines where you need to make modifications to the infrastructure that's in your network. That's what you would do with services. And you can see I just created kind of a dummy one. When you create one, you're also going to be given a access key in which whatever is trying to access this piece of infrastructure will use. And so you can see like you can generate keys here, you can give it access to particular resources. But the general idea is anything that you want to give programmatic access to, you would create a service key for that piece of infrastructure and then generate the key and then add the resource as the permission. This is one of the strengths of kind of the zero trust model where you need to explicitly give permission to everything. So that's a little bit about service accounts. Now I want to talk about some of the more interesting stuff in terms of additional security layers that you can add on top, including device security. So if we go into the devices section, we can see that, here's me. This is my Windows device that I use to connect. And if I click on this device in particular, you can see even more information about this device. You can see the name of it, what my username was, Windows, what version I'm on, the serial number if I wanted to show what type of internet security I have. You can also see different security parameters as well. So antivirus enabled, firewall enabled. I don't have HD encryption. I don't have screen lock enabled. Now, the reason this is important is because you can actually add policies that enforce that some of these criteria need to be met and then associate them so that in order to access a particular resource, maybe I need to have screen lock enabled or HD encryption enabled or all of the above enabled. And you can add even more of these security policies if you're on different types of devices. So let's go back here. Now, since I only have one device to connect with, there's nothing really to see. If you go to security here, this is where you can create these things called trusted profiles. So if you want to have particular types of checks that need to be done in order to attach them to a specific, something called a policy, you can create them here. So I already created one that's for, I called it Windows all the things. So you can go into this policy and you can see it's called Windows all the things. We have a bunch of verification requirements. We have manual trust. You can connect it to CrowdStrike, Intune, SentinelOne. You can also enforce some of these options here like we saw previously. So HD encryption, screen lock, firewall, antivirus, a bunch of really cool stuff. And then what you can do is you can associate this with a thing called a policy. And a policy is on this tab over here. And with policies, you're able to add additional security constraints either across the network or on individual sets of resources. So by default, there's just a default policy that exists. And if you click on this policy, you can change some of the rules. So you can change the authentication requirements to say that you must authenticate every 5 days. We can change this to 7 or 10 or 365, whatever it may be. You can also require MFA or multi-factor authentication, either via biometrics or some kind of secondary device. But this is just the default, right? So let's go back and create a new policy and associate this. Let's just call this other policy. And we're going to associate it with the trusted profile that we just created previously and kind of inherit all those rules. So we can go to other policy here. We can also go to manage now, and we can say either only for trusted profiles, or we're going to go to custom where we can specify that we want Windows all the things and the minimum OS requirements across all these different types. So we can just confirm this, and then we can associate it with a particular resource later. So this is how policies work and how you can add additional layers of security to your network. There's also some options for internet security. You can enable secure DNS if you'd like. You can read all about it here, but these are just some additional features that you can read about, totally optional to enable as well. Like you can see, it's an extra layer of security for your network. And so this is kind of the overview of the Twingate homepage in terms of kind of how it works and what it looks like from an administrative perspective. But let me show you kind of like what it looks like from a user. Like say you're someone that now wants to connect to an EC2 instance, for example, what would you have to do if that EC2 instance is a private one and it's connected to the Twingate network? So the first thing you have to do is you have to download a Twingate client, which you can do by clicking this button. And then your administrator would need to either create a user for you, or if they imported their users via Okta or Google Workspaces, then you can just use those credentials. But I already have an account, right? I have one for myself as a user. So this is what the Twingate client looks like. So all you'd have to do when initially setting up is that you just put the name of your network. As you can see, it's the same as right here. So beabetterdev1.twingate.com, beabetterdev1.twingate.com. We're going to click on join network. It should ask me to verify and log in, which it's doing here. So I'm going to sign in with Google. Okay, so I'm going to go to continue here. And now I'm authenticated. So in the tray of my machine right now, I can see that like the Twingate client is open, and I am now able to access all of the resources that are in this network. So let me close this. And if you remember this EC2 instance, this doesn't have a public IP address, right? Like this is completely private. It's only accessible if I'm already in my AWS account and SSH to like a jump box or something, but it only has this private IPv4 address, or if you want, you can use the private IPv4 DNS. And now because I am on the Twingate network and connected to it from my home machine, and so what I can do is I can open up my terminal or my PowerShell here, and I can just type a command to SSH into this machine as if I was like in a on-premise network with this EC2 instance. And this is all going to work like pretty seamlessly. So I'm just SSHing, I'm adding my PEM file here, and here's the private DNS of this machine, which you can verify just by looking down here. I'm just going to press enter now, and you can see I'll be able to connect to this instance. Now I'm here, I'm in ECS or EC2 rather. I can do whatever I want. I can connect to this. And so you can see how easy it is to set up. And so if you wanted, you can create like another EC2 instance, like I can launch a new instance. Then all I would have to do is go back to the network tab and then add an additional resource here just by clicking add resource. And then you can start assigning all of the different permissions. And this is where you would like assign that custom policy, the other policies, so that only, like I said, like HD encryption needs to be enabled and stuff. So this is an overview of Twingate in the console. It's very, very simple to set up, very easy to use. If you want to see a walkthrough step-by-step, check out that other video. But yeah, this is Twingate in action. So that's Twingate, a zero trust networking solution that makes it easy and secure to access your AWS resources. Honestly, I've been using Twingate for many months now in my personal projects, and it's been an absolute pleasure to use. If you're a small company looking for a VPN option, or even a larger one looking for a more feature-rich and robust zero-trust VPN solution, then Twingate is the right product for you. If you'd like to give Twingate a try, you can get started for free with the free tier at twingate.com.